You should pray that you do not get this situation, a question like this, on your SAT. The answer is D. We are going to need to complete the square twice. Why? Well, we have a circle, but that circle is not in its proper form, right? Just like with lines, we have y equals mx plus b. That's the safe place we want to get back to. Circles have their own equation that we want. It is x minus h squared plus y minus k squared equals r squared, the radius squared. So hk is the center, r is the radius. This is the ideal format. And as we can see, this version that we were given is not correct. It is not the right format for the circle. So in order to do it, we have to do something very, very complicated and annoying. Complete the square. We've got to do it twice. Once for the x's, once for the y's. If you don't learn this, that's okay. This is really only necessary for someone shooting for that perfect 800. This is not a skill that you should be wasting your time on if you're in the 500s or 600s. You've got other priorities. But here's how we do it. First, I'd look at the x's. X squared minus 6x. To complete the square, we look at the b term of our quadratic, so in this case, negative 6, and then we take half of it and square it. So in this case, we're going to get plus 9. Okay, so negative 6, half of negative 6 is negative 3. Negative 3 squared is 9. So we're going to add that in. And that's going to let us turn this quadratic now into a squared term, I guess. So basically, we would normally, if we had any quadratic equation, we would factor to find the two x-intercepts, right? You get those two things in parentheses. But in this particular case, we are designing a situation where when we factor, the two factors that we get are the same thing. So think about it. What would both multiply to 9 and add to negative 6? X minus 3 times x minus 3. So that would get us x minus 3 squared. And now we have something that kind of looks like the x minus h part of this circle, of this normal equation. So we've got to do the exact same thing for the y. So y squared plus 4y is also going to have to go through this process. So we take half of the 4 is 2, square it, so that's another 4 that gets added in. And so this becomes y plus 2 squared. And if you're still confused about where that part is coming from, just FOIL that out, right? So take y plus 2, multiply by y plus 2, you're going to get y squared plus 4y plus 4. So now we have most of our equation in the way that we want it. We have x minus 3 squared plus y plus 2 squared, and that's supposed to be equal to the radius. So in this case, it looks like it's equal to 9. However, we've got to be careful because we did something bad when we completed this square, at least temporarily bad. We just kind of made up some numbers that we're adding into our equation, right? 9 and 4. We just kind of made them up. We needed them to make the square thing complete and to do that move, but you can't just go adding numbers to equations, and so you need to maintain balance. So if we added 9 to the left side, we better add 9 to the right side as well. Same thing with that 4. That also needs to be added in. So our radius now is going to look different than it did before. 9 and 9 is 18, plus another 4 is 22. So this is just a weird looking circle. Basically, we have a center of positive 3, negative 2, and a radius of the square root of 22, which seems messy, but that's okay. We can do that. That's a number. So hopefully you don't encounter a question like this on the SAT. A lot of the times when you're asked about circles, it's just given to you in the proper format, and so you can just memorize that equation and be able to read that and find the center and the radius from there. But if we get one of these really nasty hard ones, you're going to need to learn how to complete the square. So if that's what your score's at, you've got some work to do. Practice this a couple times, and you'll be able to get these points in case they show up.